college algebra, and welcome to part 2 of our 5.2 lesson. So in other words, this is still the 5.2 video. This is now just part 2. And in part 2, we're going to be talking about applications of exponential functions involving money. And for our first topic in terms of money, we're going to talk about compound interest. Now, some of you might remember compound interest from Algebra 2, so this might be a little review. The word compounding is the act of calculating the interest earned on an investment and adding that amount to the investment automatically. So just to give you a generic example, let's say that you put $1,000 in the bank at 10% interest per year. So at the end of the year, that means you just made $100 in interest, because that's 10%. You see, that's simple interest. What compound interest does is it will compute the interest of $100 and then automatically add it to your original amount. So in other words, it does two things. It basically determines your interest and then adds it to your original amount. So in other words, when you do compound interest, it would give you $1,100, basically adding the interest to your investment. So if you want an example of compound interest, that's what it is. And the formula for compound interest is given above. Here's the main formula for compound interest, where you have P times parentheses 1 plus R over N, and then raised to the power of N times T. And each of these letters represents something different. Well, you know the T obviously represents time. The R represents the rate, and the rate will usually always be in decimal form. Just keep that in mind. And then the P represents the principal. And principal is just another word for starting amount. So in other words, when we did that example where I showed you did a $1,000 investment, that's the principal. That's the investment you put in before interest is added. And then the N, the letter N, is a new one. This is going to represent the number of compounds, or more specifically, the number of times the interest is computed and then added to your original amount. And sometimes this can vary. Sometimes you will only add interest maybe once a year. Maybe you'll add the interest 4 times a year, so on and so on. It all depends on the investment you make. So that's the one that we're commonly going to use. The second one is a special type of compound interest formula that we like to call PERT. And, well, of course, the P is still the principal, the R is still the rate, and the T is, well, still time. But the E is actually the e to the x function. And this formula you are only going to use with a certain type of compound called if you're compounding continuously. Or in other words, you're basically computing interest every second or every moment. It's continuously adding interest every moment of the investment. And that's the only time we'll ever use PERT. And of course, you guys are familiar with the function e to the x. I introduced you to that function in the part 1 video. So you guys are familiar with it. So these will be the 2 main formulas that we'll be using in this video. Just wanted to introduce you to them. And we'll get some experience using them in our calculator. And speaking of calculators, if you do not have a calculator handy with you, I recommend that you go to this website, eeweb.com/tool/calculator. It'll have all the tools you need for this lesson. So just want to make sure you have that handy. We'll be using that in today's lesson. So let's go ahead and get started. Oh, and if you haven't done so already, please take a moment to write these formulas on a separate sheet of paper off to the side, just so you can easily glance at them whenever you need them. Go ahead, pause the video, write those formulas down now. Okay, you should have written these formulas on a separate sheet of paper, so now you can easily look at them. Now let's move on. So before we look at some actual examples, I need to talk about the type of compounds that you're going to come across. In some of the examples, it won't tell you the exact number of compounds, but it will give you a word, and you're supposed to determine how many compounds that is. So the first one, let's say you have a company that tells you that it's going to compound annually. Well, when you hear the word annually, that's another word for yearly. So in other words, that would be the same as saying you get one compound a year. The second one, semi-annually, is another word for biannually. And when you hear bi, that means two, like a bicycle, which has two wheels. So that's going to be 2 compounds a year. Quarterly, well, when you think quarterly, you think 4 quarters to $1. So that would be 4 times a year. Monthly, well, there's 12 months in a year, so that's 12. Daily, well, how many days are in a year? Not including leap year. We're not including leap year. Just a regular year, that would be 365 compounds a year. So compound daily. Continuously does not have a specific number of compounds. If you see the word continuously, that's your cue to use the PERT formula to find compound interest. And we will have an example like that in this video, so you know what to expect. All right, so now let's get to an actual Hawks example. So this might actually be an example of something that you might have to deal with in the future when you're deciding how to invest your money. So Hattie has recently inherited $6,700, which she wants to deposit into a CD account. She has determined that her 2 best bets are an account that compounds annually at an annual rate of 3.1, which we will call account 1. And she also has an account that compounds daily at an annual rate of 3.5%. We're going to call this account 2. And then step 1 says which account would have more profit, or in other words, which account would give her more money. And the best way to determine this is using our compound interest formula to see, well, which one would have more money. So let's go ahead and find all the information we need so we can use that formula that I showed you on the previous slide. So let's first look at the information for account 1. Well, first, let's determine the principal, or in other words, the starting amount. Well, we've already been told that she's inherited $6,700, so that's going to be the starting amount. Then for the rate is 3.1%. I got to warn you here, though. We can't enter the rate as a percentage. We have to change it to a normal decimal. And we do that by moving the decimal 2 places to the left. And of course, right here is where we're going to have to put a 0. So in other words, instead of 3.1, you're going to say 0.031. That's what you're going to have to put for the rate. Please make sure you're careful with that. You'll always have to change your percentages to decimals. Whoops, did not mean to do that. Here we go. Next, we got to find the number of compounds. And specifically, it says right here that's going to compound annually. If you look back to your chart, annually means yearly, so that would be 1 compound. So it's compounded 1 time. And then the time, the only thing we're told, it compounds annually at an annual rate. Annual meaning yearly. Or in other words, the time is going to be 1 year. So that's the information that we'll need for account 1 to use the formula. Now let's find the information for account 2. So account 2, again, we need to find the principal or starting amount. The principal is still going to be $6,700. Then the rate, let's look. Account that compounds daily at an annual rate of 3.5%. But again, you can't enter it as a percent. You gotta change it and move the decimal over 2 places to the left. So that will make the rate 0.035. Again, please be careful with that in terms of the rate. And then look for the number of compounds, because that's what the n is, number of compounds. N is compounded daily. And daily means, well, you do it 365 times a year. So the number of compounds would be 365. And then the time we're given, that is an annual rate. So it's a rate that only goes once a year. So in other words, 1 year. Okay, so now we have all the information we need. We got the P, R, and T for each account. So now what we're going to do is we're going to have to use that formula for each account and then see which one has more profit. And then we're going to be doing that on the next slide. Okay, so let's first do account 1. So remember, we got to use that formula, P times 1 plus R over N to the N times the T. And for account 1, we said the principal was $6,700. And then we got to do 1 plus the rate, which the rate was 0.031. The number of compounds for N was 1. And then to the power of N times T, where the N, again, number of compounds is 1, and the time is 1 year. I've just plugged in all the numbers. I plugged in P, R, and T. And now all that's left for us to do is to simplify. Well, before I do any computing, I'm going to go ahead and simplify the easy stuff. Here in the power, I already have 1 times 1, which is just going to be a power of 1. And also right here, if you do 0.031 divided by 1, that doesn't really change anything. The decimal is still going to be the same. So you're still here, you're just going to have 1 plus 0.031. Okay, that's not too bad. And also, do we really need this power of 1 here? That's not really going to change anything, so I'm going to go ahead and just erase that. We don't need that. Oh, so that was easy. We just had to simplify it down to this. So now, we got to follow the order of operations. We got to do permdis. Parentheses go first. So I first got to do 1 plus 0.031. So let's do that in the calculator. 1 plus 0.031, which you guys have probably already noticed. That's just going to be 1.031. So 1.031. Now I just got to multiply that by 6,700. Let's see what that does. So 0.031, or I'm just going to take the previous answer and then multiply by 6,700. And that's going to give us our amount. Our amount is going to be $6,907.70. Let's go ahead and write that down real quick. So for this account, for account 1, we made $6,907.70. Then we'll look at the amount for account. Now we're going to get the amount for account 2. We'll compare the two amounts and see which one makes more money. All right. So now I got to do account 2 on this side. And again, I still got to use the formula. P times 1 plus R over N to the power of N times T. Okay, so first I got to do 6,700. Got to multiply by 1 plus the rate, where the rate was 0.035. The number of compounds, we said it was daily, so it's going to be 365. And then to the power of N, which 365 times T, where the T is still 1 year. All right. This one's not going to be as easy as the first one. Well, let's first simplify this part. 365 times 1, that's still going to give you 365. So 365. Out here, I'm still multiplying by 6,700. But now, I gotta take care of this part. 0.035 divided by 365. Whew, that's gonna be a big number. So let's see what that's gonna get us in the calculator. So I gotta do 0.035, and I gotta divide that by 365. Whew, that's a big number, and it also has e to the power negative 5. I'm not even gonna bother writing that all down in the on the slide. I'm just gonna go ahead and call that blob number 1. So let's just say I just computed that. I'm just gonna call it blob 1. No, that's not how you spell it. Okay, now that we have that, okay, so now we simplified as much as we could. Now again, we gotta follow the order of operations. I gotta do perm dis. Parentheses will have to go first. So in other words, I gotta do this part. I gotta do 1 plus blob 1. And I've already saved blob 1 in the calculator. And I'm going to use the previous answer trick. So I'm going to do 1 plus answer, which will literally take the previous answer, which is this, blob 1. So do 1 plus the previous answer, and let's see what we get. We get that. Looks a little bit better, but it's still pretty messy. I'm going to call this blob number 2. So now, back to the calculator. I've just computed 1 plus blob 1, and I just called it blob 2. Okay? I still got to multiply by 6,700, and I'm still raising to the power of 365. Okay, all the parentheses have been taken care of. Next order of business, exponents. So now I got to do blob 2 to the power of 365. Let's do that in the calculator. Still got blob 2 right there. Going to take, again, previous answer, or in other words, blob 2, raise that to the power of 365. This previous answer thing is so nice since you don't have to type in all those digits. So blob 2 to the power of 365 will give you that. And this, I'm going to be calling blob 3. Okay? All right, almost done. So I just did blob 2 to the power 365, and that got us blob 3 in the calculator. And it looks like the only thing I have to do now is take blob 3, multiply it by 6,700. And let's see what we get. So take blob 3, or the previous answer, which is this, and we're going to multiply that by 6,700, which is the principal. Okay, previous answer multiplied by 6,700. This should give us our final answer. $6,938.64 if we rounded to 2 decimal places. Because, I mean, we're dealing with money. We have to round to 2 decimal places. All right, so let's write that down. That the count 2 makes $6,938.64. Okay, we've done all the plugging and chugging. Now let's compare the two results. This one, 6,907. This one, 6,938. Looks like account 2 makes more money. So then the Hawks program, you're going to say account number 2 will make more money. That's what you'll put in the Hawks program. You'll say account 2 makes more money, and that's it. That's all you had to do. You got to say account 1 or account 2. In this case, account 2 made more money. Done. So that's probably the easiest way to use the formula. Basically take one step at a time in the calculator. Don't type in the whole thing all at once. And definitely take advantage of the previous answer thing. It makes it so much easier. Okay, let's move on to the next example. Step 2, same problem, just a different step. Step 2 says, from the previous problem, how much would Hattie's balance be from account 2 over 6.3 years? And then rounded 2 decimal places. So basically, Hattie realized that account 2 would make more money, and she's going to stick with it. She wants to see how much money she'll make in 6.3 years. So let's just make sure we know what our numbers are. Our principal, our starting amount, is still $6,700. The rate for account 2, if you remember, was 0.035. The number of compounds was daily, 365. The time, this time, is not 1 year. We're given a new time. We're given 6.3 years. So that will change some things for the formula. So we got our PRNT. Now we can plug it into the formula. So P, 1 plus R over N, T. All right, let's do it. So principal, 6,700. So then 1 plus R, which is 0.035, all over N, which is 365 compounds, and then raised to the power of 365 times the time, which is 6.3. Okay, this is going to be a little bit different. I would recommend we first figure out what this power is going to be. 365 times 6.3. So erase that. So we'll do 365 times 6.3, and that's going to be our power, 2299.5. So I'm just going to go ahead and erase that. I'm going to say the power is 2299.5. Just to clarify that and just get that out of the way. Okay, first things first, again, if you follow PERMDIS, we got to do parentheses first. So parentheses will be this part. So I'm going to go ahead and do this part, 0.035 divided by 365. All right, so clear. 0.035, divide that by 365. And we get that nasty number again. And again, let's just call this blob 1 so you don't have to write all those digits out. All right, so if we rewrite that, it's going to be 1 plus blob 1. All that still raised to the power of 2299.5 and still multiplied by 6,700. Okay, make some more space. Okay. We still got some parentheses left to do. I still got to do 1 plus blob 1. So let's go ahead and do that in the calculator. So 1 plus the previous answer, which is blob 1. Press enter. That's going to be our new blob. We're going to call this blob number 2. Back to the calculator. We just did 1 plus blob 1, which got us blob number 2. Still raised to the power of 2299.5. Still multiplied by 6,700. Okay, looks like parentheses is all done, according to PERMDIS. We got parentheses done. Now we got to move on to exponents. So I can now take blob 2 and raise it to the power of 2299.5. Let's do it. So blob 2, or previous answer, raised to the power, whoops, too many powers, to the power of 2299.5. Press enter. That's our new blob, which we are going to call blob number 3. All right. So I just took blob 2 to the power of 2299.5, which gets you blob number 3. And it looks like all I have left to do now is just multiply that by 700. Blob 3 times 6700. So let's do it. Previous answer, or blob 3 times 6,700. This should give us our final amount. And it looks like the amount of money she's going to make is going to be $8,352.80 if you round it 2 decimal places. So that's what she'll put into the Hawks program, that after 6.3 years, she'll make $8,352.80. So long story short, the compound interest examples are literally just plug and chug problems. You just have to be very careful when you're plugging and chugging. Take every step very carefully. Use previous answer stuff. Please do not plug in the whole formula all at once, because again, this calculator sucks at PermDis. So, with that said, I'm going to do one more example with you guys where we do similar stuff to this, and then I'll do a couple revenue problems, and then this video will be done. Whoops, wrong thing. Here we go. So, okay, so now Ellen, she's going to go through a similar situation. She has recently inherited $5,800, which she wants to deposit into an IRA account. She has determined that her two best bets are an account that compounds continuously at an annual rate of 3.4%, call that account 1, and there's going to be an account that compounds semi-annually at an annual rate of 2.8%, call this account 2. So again, we got two accounts. We need to determine which one will make more profit. So let's write down everything we need for account 1. Okay, so here's all the information we have for account 1 within this sentence. Okay, so first, let's write down what the principal is. Principal will be $5,800. Then the rate is 3.4%, but again, you got to write that as a decimal or rewrite it from a percentage, which will make that 0.034. That's going to be the rate. 3 looks off. 0.034. Okay, much better. Now, the number of compounds. It says, for this example, it compounds continuously. Now, what did we say what to do when it's compound continuously? Let's look at the chart. Compound continuously is the PERT formula. Ooh, so that means we actually don't need an N. We just need PRT, and then we'll throw the E in there to get PERT. But let's write down what the time is. We're given that it compounds at an annual rate. And of course, annual means 1 year. All right. So that's all we need, PRT, and then we'll do the E formula and go from there. But we'll do that in a second. For now, let's go ahead and quickly get the stuff for account 2. So account 2, the principal or starting amount is still $5,800. The rate, let's highlight everything that's account 2. There we go. The rate for account 2 is 2.8%, which again, you got to move the decimal over 2 places, which is going to give you 0.028 for your rate. And then the number of compounds is semi-annually, which if you look back at that chart, semi-annually, same thing as biannually, which means 2 compounds per year. And last but not least, the time. The time gives you an annual rate, meaning 1 year. Okay, we got all the information for account 1. We got all the information for account 2. Now let's see which one makes more money. So let's go ahead. Let's use our formulas. So remember, for account 1, this is going to be the PERT formula. We're not going to be using the other one that we used previously. So in other words, our principal will be 5,800. Then we're going to be using the E formula, and the E is going to be raised to the power of the rate times the time, where the rate was 0.034, and the time, which again is 1 year. So let's go ahead and compute that. Well, to start off, 0.034 times 1, that doesn't really change anything. So you don't really need that 1 there. Okay, so now we just got to follow PERMDIS. And, well, we don't really have any parentheses, but we do have exponents. We got e to the power of 0.034. So let's go ahead and do that first. Okay, clear all of this. So use your E button, which is over here. So e to the power, oh look, it's already got the power for you. E to the power of 0.034, close parentheses, and press enter. And you're going to get that gigantic decimal. We're going to go ahead and call that blob number 1. So back to here. Let's go ahead and call this blob number 1. And then all that's left is we need to multiply that by 5,800. So 5,800 times blob 1. So go back, here's blob 1, so previous answer, or blob 1 times 5,800, 5800. And that should give us our amount. Our amount is 6,059 cents. 6,059 cents. Okay, let's write that down just so we have it for reference. The amount of money we made from here is $6,000.59. Okay, that's for account 1. Now let's do some plugging and chugging for account number 2. So account number 2 does not use the PERT formula. This one's going to just use the normal one. So P times 1 plus R over N to the power of N times T. And for account 2, the principal was still 5,800. And we got to do 1 plus the rate, which the rate was 0.028. The N is 2, or biannually. Then we got to raise to the power of N times T, where N is 2 and the time is 1. Okay, now we've plugged everything in, let's compute. Well, first off, the power, 2 times 1, that's just going to give you 2, so we don't really need this 1 here anymore. That simplifies that. And it looks like we can do order of operations. We got to follow PERMDIS again. Parentheses going first. So let's go ahead and do this part, 0.028 divided by 2. Go ahead and go to the calculator, compute that. So 0.028, we're going to divide that by 2. Oh, that's actually a nice decimal. I think I can write that down. I don't need to call that blob 1. So we'll get 1 plus 0.014. All this still raised to the power of 2. And we still need to work on parentheses. So now I got to do 1 plus that. So let's go to the calculator. And I'll go ahead and do 1 plus the previous answer. Because the previous answer is still 0.014. And that's going to give us 1.014. Go down a little bit. So this will become 1.014. Still raised to the power of 2. Multiply that by 5,800. All right. So parentheses are done. Follow the next part of PERMDIS. We got to do exponents first. So now I got to do 0.014 to the power of 2. So I already got 1.0.4. So I'll do previous answer. Raise that to the power of 2. And that's going to give me that. And again, I'm kind of lazy. I'm going to go ahead and call that blob 2. So then, back to here. I just did this squared, and that got me blob 2. Now I just have to multiply that by 5,800. Blob 2 times 5800. Let's do it. So blob 2, or previous answer, times 5800. And this should give us our final amount. So from account 2, we make 5963 and then 54 cents. Because the third decimal is 5 or higher, so I got to round 3 up to 4. All right, so then in the Hawks, or no, on here, we're going to say account 2 makes 5963.54. And let's compare the two amounts. Which one makes more money? And it looks like account number 1 is the winner. It makes more money. So in the Hawks program, you'll say account number 1 will make more money. That will be your Hawks answer. So here you actually got some exposure to the PERT example, just in case if that pops up in the Hawks program, you now know how to use it. Anyway, moving on to part 2, or step 2. So from the previous problem, how much would Ellen's balance be from account 1 over 3.8 years? So in other words, the previous example, we said account 1 made more money, and that was the PERT example. So we're going to be using the same PERT formula, only this time with a new time. So the principal, still $5,800. E will be in the calculator. The rate, we still said, was 0.034. The time, this time, is going to be 3.8. Okay, make sure we got everything. We got P, we got E, we got R, and we have our new time. So let's go ahead and use those in the PERT equation. Okay, so I'm first going to have 5,800, and then E raised to the power of the rate times the time. The rate, 0.034. The time is going to be 3.8. All right, let's do it. Okay, looks like we got to take care of this part first. Let's figure out what 0.034 times 3.8 is. So clear all of this. Okay, so 0.034, we're going to multiply that by 3.8. And that's going to give us that, 0.1292. So on here, I'm going to replace this with that number. So in other words, 0.1292. That's going to be the power. All right, if I follow PERMDIS, looks like I'm going to have to do the exponent first. So e to the power of 0.1292. Or in other words, e to the power of the previous answer, because the previous answer is the power that we want. So e to the previous answer, close parentheses, press enter, and we get that giant blob. Woohoo! Yeah, I'm just going to go ahead and call that blob 1. There we go. Okay, so I computed all of this, and I got blob number 1, and it looks like I'm almost done. I just got to take blob 1 and multiply it by the principal of 5,800. So let's do it. So take the previous answer, which is blob 1, multiply it by 5,800, and let's see how much money we make. We make $6,599, and we're going to make 92 cents if you round it 2 decimal places. So for the Hawks program, you will say that after 3.8 years, you will have $6,599.92. Okay. So there you go. I feel like you guys are pretty comfortable now using the compound interest formulas, both the normal one and the PERT one. Again, please take your time using the calculator. Do not rush. Double check your work. Do not plug the entire formula into the calculator at once. All right, so now I just got to go over some revenue examples. So the revenue function is given by this equation. Now before I continue, if you're curious what revenue is, so let's say that you decide that you're going to make a bunch of coffee cups. And let's say that each coffee cup makes you take, for each coffee cup, takes $1 to make. Or in other words, you have to spend $1 for each cup. And then let's say you sell all those cups, but you sell the cups for, say, $3 each. You see what the revenue is. The revenue is the profit you make after you take away the cost. Or in other words, it's basically how much money you make after you take away the expenses. So in other words, if you spent $1 per cup to make it, but then you sold each cup for $3, that means that you made $2 in profit once you take away all the expenses that you did to make the cups. That is revenue. Basically, how much money you have left after you take care of expenses. Technically, how much money you made. So now you have an idea of what revenue is. Now let's show you a more advanced way to compute revenue. So they give you a revenue function is given by x times px, where x is the number of units sold, or this is just another word for the product. In this case, we've used cups. So the number of cups sold, and px is the unit price, or the price per cups. And it tells you if p of x is equal to this formula, find the revenue if 16 units are sold, and then round it to decimal places. So just to start from the top, we are trying to find the revenue. And it tells us that the revenue is equal to x times px. That's how we find our revenue answer. They tell us that x is the number of units sold. And does it say how many units are sold? Right here. 16 units are sold. So in other words, our x is going to be 16. And then we have to multiply that by the price, which is what p of x is. And does it give us the price? No, but it does have a formula to find the price, which is equal to this. And it looks like the formula says that we're going to take 29, and then we're going to have to multiply that by 5 to the power of negative x all over 4. Now the question is, what the heck am I supposed to put in for the x? What the heck is x? Oh, x is the number of units, which we said was 16. So for the x, you'll put in 16. But of course, the negative in front will mean that it's going to be negative 16. So let's see what happens when we do all that. So over here, I'm going to have 5 to the power of negative 16 over 4. And I'm still going to be multiplying all that by 29, and then multiplying that all by 16. Okay? So, if we simplify this down, well, we can first take care of negative 16 divided by 4. That's just going to give you a power of negative 4. And then let's see what negative 5 to the power of 4 is. Let's go to our little calculator. Clear. So let's do 5 to the power of negative. Make sure you use this with your negative button. Negative 4. And we're going to get that decimal, 0.0016. So 0.0016. All right, now we just got to multiply that by 29, and then we just got to multiply that by 16. So 16 times 9 times 0.0.6, and that will give us the revenue. Easy peasy, just like that. So let's do it. 16 times 29 times the previous answer. So the previous answer is 0.0016. All right, press enter. We should have our revenue. Our revenue is 0.7424. Ew, that's not a lot of profit. So after selling 16 units of whatever, or 16 cups, for example, your profit is only 74 cents. So we probably either need to sell some more units, or we need to decrease the cost of making these units. So that's probably a sign to say we need to fix something to make a little bit more profit. Let's take a look at another example where we use revenue. So the revenue function, again, is given by x times p of x, where x is the number of units sold and p of x is the unit price. And we're given the price formula is 29 times 2 to the power of negative x over 7. And now find the revenue if 14 units are sold, and then round to 2 decimal places. So again, to find our revenue, we got to do x times p of x, or the number of units times the price. X, again, is the number of units, and the number of units we have sold is 14. That we're good so far. Now, p of x is going to be the price, and here is the formula to find the price. Or in other words, we got to do 49 times 2 to the power of negative x over 7, where x is the number of units, which is going to be 14. So for x, we're going to put 14. So let's go ahead and do that. A bit more space. Okay. So here we got 14. We're still multiplying that by 49. And over here, we're going to have 2 to the power of negative 14, because remember the power had a negative, so negative 14 over 7. But of course, the negative 14 over 7 just reduces to negative 2. Okay, so let's first figure out what this is. What is 2 to the power of negative 2? So go to the calculator, clear. 2 to the power of negative 2. And that's going to give us 0.25. So 0.25, just got to multiply that by 49, and then multiply that by 14, and that will give us the revenue. So let's go ahead and do that. 14 times 49 times 0.25. Okay, so 14 times 49 times 0.25. Press enter, and that is going to be our revenue, $171.50. That actually seems like a much better revenue, $171.50. And that was only after selling 14 units or 14 items. If you sell a bit more, you could probably make a bit more money. So whatever this company is doing, they're making, well, a lot better than the previous example. All right, so you know how to find revenue now. You know how to do compound interest. Just some examples of using mathematics in order to make money. And with that, that wraps up part 2. Go ahead and watch the video for part 3 when you can, and I will see you guys later.